Hello, thank you for coming to the after lunch session of PyCon on a Saturday. Our speaker today will talk about analyzing a Twitter bot using TextBlob, NLTK, and Python. And he's Lachlan Blackhall. He's the co-founder and CTO of Repository Power Technologies, an Australian technology company that does things with meters and electricity. And he's also a Python user of old and one of the organizers of this conference. So please give a hand and a welcome to Lachlan Blackhall.
Oh, good afternoon, everyone. I hope you had a nice break over lunch. It's a real pleasure to be here to give a talk, as always, and I'm going to give you a talk in an area in which I have absolutely no expertise. So what I'd like to do as I sort of take you through the topic is really sort of tell you a bit of a story about how I came to be using TextBlob and how I came to be sort of investigating natural language processing, which if you know my background, is quite theoretical and technical, you'd realize that sort of language is not my primary area of strength. So what I'd like to talk about today is something called natural language processing. Most of you have probably heard about it. If you haven't, natural language processing is basically computational techniques for analyzing language. And increasingly, it's becoming more and more important that we understand this, particularly as we start to talk about artificial intelligence and machines taking over the world and whatnot. It's probably going to be a good idea that we have some way of understanding the computers and that hopefully the computers have some way of understanding us. But where you tend to see a lot of the work being done at the moment, particularly in the research area, is things around sort of conversational interfaces. And so there's been a lot of talk about this in the last 2 to 3 years, which is really focused on actually being able to have sort of text-based interactions with computers where computers can actually understand what it is we're trying to say to them. And so my interest in this actually has come from sort of a background of I saw some interesting articles about conversational user interfaces a few years ago, and I thought that sounds really awesome. Like it'd be great to actually for computers to be able to actually understand users, and particularly I'm a controls engineer, so I work in sort of very, very deep embedded systems. It's like it would be really, really interesting to be able to marry kind of those deep technical concepts that I work in and I love with consumers, users being able to actually ask questions that we could then, as a programmer, sort of semantically pass and use to actually change or modify or even to explain to the user what we're doing sort of deep down in the guts of the system. So that's really where my interest in natural language processing has kind of come from. And what I'd like to do for you today is to tell you a little bit about a really interesting Python library that makes doing NLP stuff relatively simple, and then take you through a bit of a side project I've been working on. So in the title, we said we were going to talk about Twitter bots. So it probably is helpful to start with what is a Twitter bot. And I've chosen one of my favorites, one of my wife's favorites, which will become clear why that's relevant in a minute. And it's called the Magical Realism Bot. And Twitter bots are essentially just, they're automated pieces of code or automated systems that sit there and basically post stuff to Twitter. And in this instance, the Magical Realism Bot, it's pretty awesome. It posts tweets, which are the synopses of far-fetched stories. And so these are only sort of a handful of the 3,500 or 4,000 tweets that this Twitter bot has made over the last couple of years. And they're absolutely wonderful. And when you read through some of the tweets that have come out of this thing, they're just flawless in the way that they have created these synopses for the stories. And this this was really interesting to me because you've got this Twitter bot that every couple of hours spits out a new story that automatically makes sense. Like we can read this and you can understand it, and you can see that it's sort of far-fetched and fantastic, but it actually does make sense to us in English, which is pretty amazing, I thought, from an automated process. So the reason why I became a lot more interested in this was that my wife and I have discussed many, many times how I should actually use my Python expertise to help her out with her side projects. And so I sort of finally relented on this one. And this talk is also a lot about the hubris of a Python programmer. She said to me one afternoon, look, I really love this Twitter bot. Wouldn't it be great if I could also have a Twitter bot that created stories in another area? I was like, yeah, that'd be wonderful. And we could use Python, just totally reverse engineer the whole thing. Really simple. I'll knock it off. Next week, you'll be doing it. We'll both be famous. Wouldn't that be great? So this, you'll see through this talk that it's turned into much more of an epic side project than the sort of afternoon I thought it would take. But ultimately, this is all down to my wife, Elle, who sort of put me on the path to actually trying to understand this Twitter bot in an automated way. So, and the reason that that I got really interested in sort of how you might approach understanding how these tweets are generated comes from the fact that the author of the software that actually generates this, at Yeldora, she's actually an Australian school teacher, I believe based in Sydney. And so she's been, and her brother is the guy basically behind the magical realism bot. And so both of them have been quite open about how they've gone about implementing it. And it's also implemented in Python. And from the tweet, you can see, and then from a sort of a snapshot of an article I've pasted, you can understand that they're using nested templates. And that makes perfect sense. All right, so they're creating these sort of tweet-sized templates. They're creating some form of word list, and then they're populating their templates with the word list. And my understanding from what I've sort of read and what I've seen when they've done Q&A is that essentially they don't really do any cleanup of what's produced. So it's not like they're producing rubbish and then manually cleaning it up by hand. My understanding is that their system is able to systematically fill in these templates that they have and ensure that tenses and singulars and versus plural is all handled. So I thought that was pretty impressive in terms of the sort of the forward direction, and we're trying to go now somewhat in the reverse direction to actually see if we can try and unearth the templates that they were using. And the reason that I thought it would be something that we could do easily in Python is that where you have some underlying structure, that's what computers are really good at, and as programmers we often try to discover the underlying structure. So I thought that's why I thought it'd be a nice sort of Sunday afternoon project, earn a few brownie points, and obviously get famous with our own Twitter bot. So the first step that we took to start this was actually pretty mundane. To actually just grab the tweets, and so it's really easy to retrieve tweets from Twitter using Tweepy or Tweepy, and there's this really nice gist that actually basically sets it out for you. So collecting the tweets is actually relatively simple. You can't collect all of them in the manner that they describe here, but you can collect about 2,600 at a go, which was plenty for sort of for what I was looking to do with it. So grabbing the tweets, putting them into a CSV file, that was all pretty simple. So the next step was, I always thought of this as a natural language processing type problem, and so I'd been really looking for an excuse to use a Python package called TextBlob for some time. So this is a perfect example of where we could start to use TextBlob. Now, TextBlob is essentially a Python wrapper around NLTK. So NLTK is the natural language toolkit It was developed by a couple of professors at the University of Pennsylvania, and its first release was in 2001. And so it's very well regarded in terms of the natural language processing that it can do, and has obviously been developed over many, many years. And so TextBlob is essentially a wrapper around NLTK. It just makes it a little bit easier to use some of the underlying methods, and it sort of shortcuts the process of setting up certain things within natural language processing. So it's really, really good, actually. I think TextBlob's it's a well-maintained library, and it's very easy to wrap your head around what's actually going on there. So installation's easy. This one's just worth touching on, actually. You do the pip install of TextBlob, and that's fine. That also grabs you some of the that grabs you the NLTK package as well, which is also a Python package. The way that natural language processing works is it typically uses a corpus of text, or what's the plural? Something in Latin? Corpora, there we go. And so what that means is you end up with these large tagged text-based data sets. And that's how, when you start doing the analysis, they're basically going back and forth into these tagged data sets to actually do the analysis. So you can grab the software, but you can't actually do much useful stuff until you actually download the corpora, which is actually really easy to do. So you type the command in and you get a whole bunch of stuff. You can use either method there. So TextBlob has a wrapper around the actual underlying NLTK corpora downloader. And if space is a concern, you don't have to use all. You can actually pull out different corpora that you actually need for the particular problem that you're working on. So yeah, easy to get started, and very, very quick to download. So just to give you an idea of some of the capabilities of what TextBlob can actually do, ultimately we're talking about doing analysis on pieces of text. So for everything we're going to talk about here, I'm basically going to talk about the analysis on individual tweets. And so we're going to redo all this analysis for each of the individual tweets in the 2600 that we downloaded. So you import TextBlob, you get your string, you load it up into this TextBlob object, and then you can sort of unleash its analytic capabilities. So you can get the sentences that are there, which probably doesn't sound super, super useful, but in lots of cases it is. It can do language detection, which I believe it actually does through interfacing to Google. So that's probably the only gotcha here. Most of TextBlob runs offline, but I found out the other day that if you're not online, it does blow up because it actually does try to go to Google for some things. It can do word counts, it can get noun phrases, and we'll talk a bit about them in a minute. And it can do this thing we call part-of-speech tagging. And we're going to spend most of our time on part-of-speech tagging today because I think it's pretty incredible what you can do with it. So just to break out what you'd expect for each of these. So if you get the sentences, it returns, conveniently enough, the sentences. There's probably nothing unexpected there. The nice thing is, most of these tweets are only 1 or 2 sentences, so you're probably not going to be using this kind of capability a lot there. But when you end up with large numbers of sentences or a very, very large corpus of text, you might find it very, very convenient to break it down into sentences to do your analysis. So, for example, we're not going to talk about neural networks at all today, but when you do neural network analysis on text, you typically want to feed it fixed length pieces of content. And so one way you could do that is you might break it down into these sentences, pad all the sentences to constant length, and then you'd be able to feed it all straight into a neural net to do analysis that way. So there are reasons why you would use a lot of these methods. You can do language detection, so it worked out that we have English, which is useful perhaps. You can get the word counts from it. And so, given that every word's unique here, we get a dictionary of unique words. But again, over a very, very large corpus of text, it might be really interesting to you to understand what the common words are. And I'll actually talk a little bit later about how I was able to analyze all of the texts all of the tweets, sorry, in a single corpus and actually extract some useful stuff from that. So you can get into noun phrases. So noun phrases are things like the subject and the object of a sentence, and so TextBlob and NLTK can actually pull them out relatively automatically for you. So that's kind of interesting if you're looking at doing sort of semantic analysis and understanding what the person's actually, what's actually being asked in the sentence or what's being referenced in the sentence. And then you can do tagging. And so, as I said, this is what I'm going to focus on for the rest of the talk. So essentially what the tagging does is it tags for every word in a sentence or in a corpus. It actually it tags it with the type of word it is. So A is a determiner. Made is a verb. Romans a proper noun. And the interesting thing about why you'd want to use this kind of analysis is there's tens of thousands of words in the English language, but the tagging turns out there's only about 30 unique tags that you can use to tag all these pieces of speech. And so this, I thought, was the correct attack vector to actually try and solve this problem of understanding what the Twitter bot was doing. So you can see through here there's, you would have come across most of these parts of speech through your education, but perhaps not quite as formally when you think of it being structured like this. So this is something that's called the Penn Treebank part of speech tag set, and this is what NLTK uses as its default tagger to actually go through and tag parts of speech. So the question that I thought would be interesting to answer and might actually allow us to really understand what was going on in this Twitter bot was to see if you could actually generate meaningful sentences using only structured parts of speech tagging. So rather than you'd go to a neural net and try and learn all these tweets and then hopefully the neural net would be able to spit you out a tweet that's sort of similar to one of the tweets it's seen before, I thought, no, let's not use a neural net. Let's see if we can actually go from a string or a sentence of parts of speech tagging back into a meaningful tweet in English. So it's obviously easy to go the first direction from the sentence to the parts of speech tag, but can you go in the reverse direction? So that was my hypothesis, or the question that I set out to answer in all of this. So the way I approached it, for every tweet, went through, pulled out the parts of speech tagging. I created these parts of speech tagging sentences. So this is obviously not a sentence, it's meaningless, but it's the collection of parts of speech that constituted the original tweet that we started with. And the second thing I did was I also created a corpus of words for each type of part of speech. So as we go through this tweet, we say, well, the first type of part of speech was a determiner, so that goes in the first part of the sentence. And we also record that in this determiner dictionary, we've seen the word "ah." So hopefully that all makes sense as to what we're doing there. So really all we're trying to do is, rather than trying to analyze this Twitter bot from the perspective of analyzing the tweets, we're trying to analyze it from the perspective of using the parts of speech that were there. And the reason I thought that would be an interesting way to do it is that I thought the structure, if you actually have a nested template, that the template actually represents in lots of cases things like, verbs and adjectives that you're drawing from a list. And so rather than trying to deal with all of the words that are there, you try and just deal with the parts of speech from which these templates were actually composed. So that was my my thought on how it would work. So the second thing I did was I took these parts of speech sentences and I encoded them into something called a directed acyclic word graph using this. And don't worry, this is not actually crucial to what's going, but it is what I did first. So a directed acyclic word graph is simply what you see here on the right-hand side. It's that for a given set of characters or a given set of symbols, you just encode it in a way that allows you to represent the possible choices here. Because remember, my goal here was to reverse engineer this Twitter bot for my wife. So I actually needed to have this kind of like minimal representation of all the structure. And so I'm not doing it with the words, I'm now doing it with the parts of speech. And so this is actually a tree, and this is the dog, I think, which is an interesting pronunciation. So I was like, that's fine. And then I was like, once it's in a directed acyclic word graph, then it's really simple. Because once you've got that, you can guarantee that you can produce a minimal regex of these parts of speech. You can generate a random sentence of parts of speech that come out of this. And I was like, once you've got that, then you can go back, and for each part of speech, you can pop in a word from your word list. And I was like, and it's going to be amazing. Like, once we're going to do this, we're going to be able to totally reverse engineer this, and we are going to be able to produce tweets that are totally independent of the original Twitter bot. And so we got these amazing story synopses from the reverse engineered approach. And as you can tell, they don't make a lot of sense, except for the last one here, which I think is actually quite a deep comment on society. But with appropriate grammar, I think you can make the last sentence actually make sense. So the thing, this was the hubris part of it, because I suddenly realized, of course, which is something we all know, but of course English is extraordinarily structured, and it's very complex, and it takes us ages to learn. And the reason it takes so long to learn is there's so many different rules and exceptions to how you actually construct meaningful content. And so, you know, I suppose, long story short, to think that you could actually, from 30 different parts of speech, reverse engineer and get sentences that made sense is kind of perhaps a little bit bold. But nonetheless, I wasn't deterred, because particularly after I realized the last sentence made sense, I thought, well, look, there's probably hope that we can actually start to analyze this in a different way. And see what we can get out of it. So it's pretty clear that what's missing is structure here. So we're choosing all these random words from a word list, and so we're choosing nouns against verbs, and it might not necessarily, they might not make sense. Like, they're, you know, as individual words they're fine, but once you start constructing them into sentences, they make absolutely no sense. And my hypothesis was that, well, maybe you actually need just a bit more structure here, and then you can still do this. And so I started with, you know, this as an example tweet, and then, you know, converted into this part of speech string. But rather than just trying to generate a tweet directly from that, I was able to use the word count feature I talked earlier to try and find common words and phrases that existed within all the tweets. And so based on that, I found that there were a lot of tweets that had this kind of structure here, where there was like parts of speech and then made of, and then another part of speech. And so I thought, well, maybe this is the right way to do it. This is the way of introducing some structure, so there's not so much free form that we're trying to free-form words that we're trying to generate. And so these were some of the tweets that we were able that started to emerge. And so and you know, all of these, I mean, they might seem ludicrous, but then the corpus of words that they were drawn from was ludicrous to begin with, but they do make sense in English. And particularly the first one struck me, because as an entrepreneur, I often feel like I'm made of panic. And so I suppose what you start to come to realize is that these parts of speech, some of them actually form really simple structures that you can actually generate with relative ease. And so this is actually a really common structure in, particularly in these tweets, but in language as well, where you have determiner, adjective, adjective, or multiple adjectives, and then a noun. And so you can generate these at will. Almost 100% of the ones you generate make sense. And these were some of the ones that sort of started to emerge, and I thought they were quite entertaining. But I think the overarching thing that I unfortunately discovered is that there's not quite so simple a translation between these parts of speech and the ability to generate sort of arbitrary phrases and sentences that you'd want to actually be able to sort of perfectly reverse engineer a Twitter bot like this. So once I sort of accepted that, I sort of got into this mindset of, well, how would you actually go about doing this practically in terms of reverse engineering it? And it turns out that, you know, the reality is there's lots of chunks that look like this that in short, you know, for 3, 4, or 5 parts of speech, it's really, really easy to generate like actually meaningful content from them. But you do have to find these structural pivots. And those pivots would have been the things in the underlying templates, like made of, where made of is actually always in the template, and it's the other parts that are generated automatically by this Twitter bot. So unfortunately, the work on this is going to have to continue. I haven't actually told my wife that I'm sort of becoming a little disheartened with the whole affair just yet. But the really interesting part is, you know, it really did remind me of sort of the really critical structure that is in language and how complex it is to understand it. It was a really great experience in learning and understanding what TextBlob could do, and you know, hopefully a good reminder that reverse engineering humans is still a pretty challenging task yet. So we're probably safe. We're probably safe from robots for a while yet, particularly if I'm going to be programming them. So I will. I probably will continue with this because I am now actually keen to sort of see it through and see how much of the original content you actually can reverse engineer automatically. So just in winding up, I've only touched on a really simple couple of things that TextBlob can do. TextBlob actually is immensely powerful. It can do sentiment analysis. So given a piece of text, it can actually tell you whether the text is generally happy, generally sad, or generally neutral. It can do tokenization, which is stripping all your content into chunks, so into word chunks or into sentence chunks, which we talked about before. It can do lemmatization, which is actually really cool. It'll convert any word into the equivalent word that's likely to be in the dictionary. So for example, if you have the word octopi, when you do lemmatization on it, it'll turn it to octopus. And that's might sound irrelevant, but when you're trying to actually automatically understand what's going on in a piece of text, you actually want to make sure that you can try and work with the reduced form of the word always. And so this gives you a way to come back to one form from any pluralization and things like that. So that's actually really quite useful as well. It does spelling correction. I believe that's also through Google. It can do translation, and the list goes on and on and on. So as I said, the documentation for it is really wonderful, as is the documentation for NLTK. So that's all from me, and happy to take any questions you might have.
So thank you. We are good for one question, so.
I hope I make it a good one, mate. Yeah, love your talk. Just a quick one. So do you think there's any use for context-free grammars to help analyse tweets?
Look, this is by no means my area of expertise, so I'm sure there is. The reason I wanted to do it this way is I'm really quite interested in algorithms that are really easy to explain, and so this one to me was sort of nice and simple. It was just a mapping from one to the other. So yeah. I mean, there's plenty of experts who are going to solve this better than me, hacking around with parts of speech, I suspect.
That was very brief. If someone else has one very short question too, I can get to you. Yes?
I was just wondering whether enhancing that 30 tag list of unique tags would be a pathway to making the system work a bit more effectively.
Yeah, that's really interesting. Actually, I went the other way. I went the other way initially. If you look at these, I actually initially started by reducing all of them, so all of the nouns to a common one, because I thought that might be easier. And it wasn't, so I suspect that the correct path is potentially to go further. The other challenge too might have been that because this was using sort of some it was a fantastical corpus that was input into it. Potentially the challenge was that it was already a set of words that might not be a perfect choice for actually reconstructing in the opposite direction. So yeah, food for future work.
Thank you, Lachlan. And on behalf of PyCon Australia, I'd like to gift you with a mug for speakers.
Thank you very much.